Okay guys, welcome back. So in this video I'll be talking about the inclusion of algebraic expressions in the case of partial fractions. Now in the last video and the video before the last I explained to you about different types of partial fractions, but I didn't include either a linear expression or a quadratic expression to make this partial fraction. Now let's take a simple example. Now if you are given something like this, say x cubed plus 3x plus 8 over x minus 4 times x plus 3, right? X minus 4 times x plus 3. So you know that the highest power of the numerator is 3 and the highest power of the denominator is 2. So the highest power of the denominator minus the highest power of the numerator minus the highest power of the denominator is 3 minus 2, which is 1. So we are left with 1. So we can write a function in which we have a power of 1. So we can write easily a linear expression here. So you can say that this is equal to a divided by x minus 4 because we have a function here, plus b divided by x plus 3 because we have a linear function here, because that is not equal, because when you divide the highest power of the numerator by the highest power of the denominator, you will be given with some function in which you can write a linear expression. So what I will write here is that since we are left with equation in which the difference of powers is 1, I can write a linear expression here, which is, I will write ax plus b plus that those two fractions still remain the same. So I'll take the c divided by x minus 4 or c over x minus 4 plus d over x minus 3, x plus 3, d over x plus 3. I have to write here c, not cx plus d or something like that, because the highest power of here is 1. So I have to write a fraction in which the highest power is 1 minus 1, which is 0. So any function which has 0 power is a constant, right? Again here also the same. So the set of fractions, the set of partial fractions for such a function or for such a fraction like this will be as follows, right? As this. Alright. So similarly, what I do as the second step is that I have to multiply both sides by the denominator of the function that we have been given. So the denominator of the function we have been given is x minus 4 times x plus 3. So when you multiply both sides by x minus 4 times x plus 3, I will get the numerator here, because the denominator and that function will cancel off. I will get the left over with the numerator. So that will be x cubed plus 3x plus 8 equals, now when I multiply x minus 4 plus x minus 4 times x plus 3 by ax, I will left over with, because there is no function to cancel off, I will get the whole function here. That will be x minus 4 x plus 3, right? Plus b also, when I multiply it will be the same. I will get the whole function, whole denominator, x plus 3, right? Plus c. When I come to c, this x minus 4 and this x minus 4 will cancel off when they are multiplied, and I am left with x plus 3. So that will be c times x plus 3, x plus 3, and when I come to d, this x plus 3 and this x plus 3 will cancel off when I multiply, so I am left over with x minus 4. So I have multiplied d by x minus 4. So I take this to be equation number 1. Now as I have been doing throughout these videos, what I do is that to equate the coefficient of different terms. Now I can take actually 4 terms here: x cubes, right? X cubes, x squareds, x's and constants. So first of all, if I equate the x cube terms, I am left over with 1 here, and the only x cube term I will be getting from the right hand side is by a. When I multiply ax times x, I will get x cube. None of the other terms will give me an x cube term. So ax times x is ax cube. So the coefficient of x cube is a. So a is equal to 1. So we found a directly. we found A directly. So when to find other things, I'll easily equate the other terms, x squared next. So x squared in this side is 0 because there is no term of x squared. So that will be 0 equals, I'll get an x squared here, so we can say this one has x squared. You can simplify, it's better to simplify the term here. So x squared minus 7x plus 12. So when I multiply ax by x squared, I will get ax cubed, so I got that. So to get x squared, I need to multiply ax by the x term, which is ax times minus 7x, which is minus 7ax squared. So the coefficient of x squared is here minus 7a. Minus 7a. It's always better to solve this if you have brackets, a number of brackets here, because it's easy to find this rather than taking this one like this, going through curves, like arrows and something like that. It's easy to solve this first and then take it into the equations. So the next term I'll get another square term with b also. So b times x is bx squared. So the coefficient of x squared is b. So this is minus 7a plus b is equal to 0. So I'll not get x squared with c and d because I have linear expressions here. So from this one I can easily say that b is equal to 7a because 0 is equal to 7a minus 7a plus b. I can say b is equal to 7a. So I found the value of a to be 1. So b is now equal to 7 times 1, which is 7. So I can find the value of b also directly. Now to find the value of c and d, first of all I will equate the x terms. So when I equate the x terms, I am left over on the right side with 3x. Right? Sorry, on the left side with 3x. So it will be 3 equals, and on the right side I will get an exam here when I multiply ax by 12, right? Ax by 12. That's why I told you as always to solve this. It's easy to find now. When I multiply ax by 12, I will get 12ax. So the coefficient of x will be 12a. So 3 will be 12a, and for b, I can solve this to be again x squared minus 7x plus 12 inside the brackets. So when I multiply b by 12, so b by minus 7x, I'll get another x term, which is minus 7b, the coefficient of x, minus 7b. When I multiply it by c, I'll get cx, so the coefficient is c. When I multiply by d, I'll get dx, so the coefficient is d. So I can substitute the values of a and b to get an equation for c and d. So a is equal to 1, b is equal to 7, so 12 times 1 is 12, minus 7 times 7 is minus 49, so 12 minus 49 is minus 37. That minus 37 when I take to this side will be 40, so 40 is equal to c plus d. So this I'll take as equation number 2 because I already took this one as equation number 1. And now I have two unknown terms, so I need two equations. So I already have one equation, so I need to get another equation. So my next equation will be by equating the constants. When I equate the constants for both sides, I have 8 here, plus 8 on the right side. So 8 will be equal to, so since we have ax here, we will not get a constant term, because when x is multiplied by any term, we will get either x or a power greater than x, right? So when I multiply b by this function, since we don't have x's here, I'll get a constant term which is b times 12, 12b, so the coefficient will be 12b. So 8 equals 12b. And for c, when I multiply c by plus 3, I'll get another constant which is plus 3c, and when I multiply d by minus 4, I'll get another constant which is minus 4d. So I'll also get plus 3c minus 4d. So b is equal to 7. 12 times 7 is 84, and when I take this side, 8 minus 84 is minus 76. So I can say minus 76 is equal to 3c minus 4d, which will be my third equation. Now I have two equations and two unknown terms. I need to solve for c and d. So my first equation will be 40 equals c plus d. This is equation number 2. and the next equation is minus 76 equals 3c minus 4d, 3c minus 4d, which is equation number 3, right? Equation number 3. So I can easily find the value of c by multiplying this term by 4 and adding these two terms, adding these two equations. So when I multiply this second by 4, 40 times 4 is 160, 4 times c is 4c, and 4 times d is 4d. I'll take this to be equation number 4. When I add equation number 4 to equation number 3, this plus 4d and this minus 4d will cancel off. So 100 is, in the left hand side I'll be left off is 160 minus 76. So 160 minus 76 is 84. 4c plus 3c is 7c. So I can say c is equal to now 12. Exactly 12. Right? So I can substitute the value of c here. C plus d is equal to 40 to this equation. So from second equation I can say 40 is equal to c plus d. So c is 12 plus d. So d is now equal to 28. Now what I'll do is, as I mentioned in the last video, I'll substitute the values of a, b and c, a, b, c and d here, a, b, c and d, to make these partial fractions. So I can say this is the given fraction on the left hand side, x cubed plus 3x plus 8 divided by x minus 4 times x plus 3 is equal to now ax plus b. So a is 1, so that will be x, 1 times x is x, plus b is plus 7 plus c over x minus 4, so c is equal to 12, so that will be 12 over x minus 4 plus d over x plus 3, so d is 28, that will be 28 over x plus 3, bracket c. So this is the term we have to actually write, right? So we can write here, therefore partial fractions, right? Therefore partial fractions is as follows, because we have to write this because we were not asked to find the values of a, b, c and d. So a, b, c and d were values that were taken by us. So we were not intended to find the value of a, b, c and d. We had expressed this in this term, but we can directly write this. We have to find some constants here. So although we found that those are not the terms that will be the expected answer for the expected final answer. So the expected final answer is in this format. So after finding the values, all the actually the terms we took, a, b, c and d, o, p, q, r, s, o, l, m, n, o, something like that, the terms we took, we have to substitute that and say this is now equal to this one. So because this is the final answer that they are expecting as the solution, right? So we have to express in this term, right? So in this video I explained to you about another actually an example in which we have to insert linear expression. But in the case when you have the difference between these two functions to be 2 or 3, say here you get x to the power 4 and here you get x squared. So the difference between the highest power of the numerator and that of the denominator is 2. So since there's the difference is 2, now we have to write not a linear expression, a quadratic expression. Say ax squared plus bx plus c, or px squared plus qx plus r, or something like that. So if you have here a difference of 3, you have to write actually a quadratic expression, right? Difference of 3, cubic expression, ax cubed plus bx squared plus cx plus d, or something like that. So you can write infinite number of fractions like this, infinite number of examples according to this format, when the difference between these two functions are different. Actually the numerator, the highest power of the numerator is greater than the denominator. So that's just a simple example. So you can do many problems using this video, what you learned in this video, and in the next video I will explain you about the same concept, about the same concept of that I explained in the first video, but about factorization of the denominator. Thanks for watching this video, and see you then.